Hello again. I hope you guys had a beautiful weekend. I'm excited to see you again. I'm sorry that I'm not on the video this time. I'm just going to be showing you guys one new thing, which is simplifying radicals. So you actually did this already at the beginning and watched a little bit of a video on it, but I'm going to just break it down a little more because I know some of you guys struggled with this, so we're going to just relearn it. So the first thing we're going to do is create a list of perfect squares. Perfect squares is anything you can take the square root of. For example, 9, 16, 100, because the square root of 100 is 10, the square root of 9 is 3, and the square root of 16 is 4. So the first one we'll do is 2 times 2 is 4, so I'm going to put 4 here. 3 times 3 is 9, 4 times 4 is 16, 25, and then I'm going to just keep going, and I've got the rest of my list right here. We're going to go as far as 169, which is 13 times 13. To simplify a radical, we come over here now, and we're going to look at this, at this problem that we have right here. Example 1. Square root of 48. My goal is to find one of these perfect squares that divides into 48. So meaning I put in my calculator 48 divided by, and then I choose one of these perfect squares. So obviously it can't be bigger than any of these numbers. So I'm going to start right around 48. I'm going to start right around here and say, hey, can I divide 48 by 36? So I just take my calculator and I put 48 divided by 36 and it gives me a decimal. So I say, can I divide 48 by 25? So that's the next one going up the list. That gives me a decimal. 48 divided by 16, and that works. So that means that this is the perfect square that divides in. So the way I break it down is I'm going to draw two little arrows and make two square roots. I always write the perfect square in the first one, so that's the 16. When I divided 48 by 16, I got 3, so I put the 3 here. Put a little time sign in the middle. Because 16 times 3 equals 48. Okay, so this makes sense. Now we take the square root of 16. So the square root of 16 is 4. That comes out of the square root. But I can't take the square root of 3, so it comes down and it stays the same way that it is. All right, we're going to try two more like that. So the next one I'm going to do is the square root of 50. Okay. And then the one after that I'm going to do is the square root of 320. Okay. So I'll start with the square root of 50. So I come over to my list and I know 49 can't go in. I tried 36, it doesn't work. I tried 25 and it does work. That's awesome. So I break it down into two. I always write my two perfect squares. Two square roots, I'm sorry. I put the perfect square in the first one. So the 25 goes here, and 50 divided by 25 leaves me with a 2. So I put a little time sign because 25 times 2 equals 50. Okay, so now we understand why. Now, okay, the square root of 25 is 5, so I can just bring that down. And I can't take the square root of 2, so it stays the same, and that's my simplified answer. 320, that's a bigger number. So I'm going to start down at the bottom here, and I'm going to just work my way up. So I try 320 divided by 169, decimal. By 144, decimal. By 121, decimal. By 100, decimal. Let me try by 81, decimal. 320 divided by 64, and it works. So I put two square root signs, and the perfect square goes in the first one. So the perfect square that worked was 64, square root of 320 divided by 64 is 5. Okay, so again, 64 times 5 equals 320, just so you understand where these numbers are coming from. The square root of 64 is 8. I can't take the square root of 5, so it comes down exactly as it looks, and that's the simplified version. If I put in my calculator square root 320, and I hit enter, this equals about 17.88854, and then it keeps going. If I write 8 square root 5, and I hit enter, it gives me the exact same thing. That's how I know that I simplified it, right. And also the number inside the radical is a nice small number that I can't break down anymore. I can't divide that by a perfect square. Okay, so now we're going to take this idea, you're going to practice that more, and we're going to go to something new. So We know what 7 squared is equal to. Awesome. 7 times 7, that's great. And that's going to be 49. That's something you guys all know. Here, if I have negative 7 squared, remember I have to multiply negative 7 times negative 7. Well, a negative times a negative still gives me positive 49. Check that out. They both gave me the exact same answer. Meaning that if I have negative 7 squared and positive 7 squared, they both equal to 49. So what is the square root of 49? Well, it can be two different answers. It can be positive 7 and it can be negative 7. Remember in the quadratic formula and in completing the square, we had to put that plus or minus sign. That's why it goes in front of the square root. So then what's the square root of negative 49? Let's think about it. Could it be 7? No, because 7 times 7 is positive. Could it be negative 7? No, because negative 7 times negative 7 is positive. So is there anything that times itself will give me a negative number? There isn't. Okay? This does not exist. It's impossible. And when it's impossible, we call that imaginary. So this is what's called an imaginary number. Okay. Take a second and I want you to visualize in your head what Santa Claus looks like. Picture him. Think about what he does. Think about what his role is. What is his job? Where does he live? You could probably tell me all these things, right? You would probably say he's a chubby guy, got a big white beard, red nose, red suit. He gives gifts to people. He sneaks into people's houses. Yeah, people have, stories. But everyone can tell me. But does he actually exist? No, right? He doesn't really exist. I'm sorry if I'm the one to break it to you. Imaginary numbers are the same way, okay? So that can't exist, just like Santa Claus. You can describe him, you can visualize him, you even know what his purpose is, but he doesn't actually exist. Imaginary numbers are the same thing. You can see them, you can do operations with them, you can work with them, but they have a purpose, but they don't actually exist. What is this? Why is this important? Well, if you notice sometimes when you did the quadratic formula or when you did completing the square, inside of the square root, you ended up with a negative number. Well, what does that mean? Let's say I did the quadratic formula and I ended up with x equals 2 plus square root negative 25 over 3 and x equals 2 minus square root negative 25 over 3. Remember, because you have to split it with the plus and the minus. Well, this tells me that inside of my radical here, I have a negative number. If I have a square root of a negative number, that can't exist. So that means that my roots here would be imaginary. I would have imaginary roots. Well, what does that look like on a graph? That would look like this. Imagine if your parabola never crosses the x-axis. Here's the x-axis. If the parabola never crosses it, there are no roots because it never crosses the x-axis. These are called imaginary roots. So imaginary roots are going to have a negative inside of the square root. Okay, so a lot of information. Take notes on it. Go slowly. Now, we're going to take a look at how we write imaginary numbers. So write this down in your notebook, okay? To write imaginary numbers, first thing you need to know is that the square root of negative 1 is equal to I. That's the most important thing. I would write that down, put a box around it, maybe some things to make it really stand out, some little fireworks, maybe a lightning bolt. That's a really bad lightning bolt. Okay, you get the idea. Make it stand out, make it important in your notes. To break it down, the square root of negative 36. So you first break it down and take out the negative 1 right here, okay? Then you say negative 1 times 36. So now I can take the square root of 36 because that's a nice number. The square root of 36 is 6. And then you write the square root of negative 1 as I. So the square root of negative 36 is equal to 6I. Okay, what it means. Imaginary solutions, we just said when you're writing them down would look like this because they have a negative inside the square root. Negative inside the square root. On a graph, it never crosses the x-axis. So if you want to take a second to jot that down, pause it. And here's 3 examples. Okay. First example is square root negative 200. So the first thing I'm going to do is I'm going to break it down with the 200 and the negative 1. Okay. I can't take the square root of 200, so I go back to my perfect square list and I say what perfect square can divide into 200? And you may have already guessed it and you were right, it's 100. So I divide this, always write the perfect square in front, and 200 divided by 100 is 2. And this just comes down the same way, okay? That's the same thing. Now we just do each one separately. So the square root of 100, that's 10. The square root of 2, I can't take it, so it comes down and stays the same. You rewrite the square root of negative 1 as I. And then the order that it goes in, you write the number first, the 10 goes first, the I goes second, and the radical goes at the end. And that's your answer. So the square root of negative 200 simplifies to 10I radical 2, and that tells you that it's imaginary, so it never crosses the x-axis. Imaginary roots. Okay, let's simplify the next one. So negative 108. First thing I do is I break down 108 and negative 1. Then I take 108 and I start around here and I say, can I divide by 121? Nope. Can I divide by 81? Nope. Can I divide by 64? Nope. Can I divide by 49? Nope. Can I divide by 36? Yes, you can. So it breaks down. You put the perfect square first. When you divide 108 by 36, you get 3. Okay, this one stays the same. And now we just simplify each one. Square root of 36 is 6. That just comes down, and this becomes I, the square root of negative 1. And the right order is 6I radical 3. And that's how you write your answer. Last one, and then that's all you have to learn for today. Break it down. So the square root of negative 125, you do 125, a positive number, and negative 1. 125, you may already notice, hey, I bet 25 can divide into it. And you are right. 125 divided by 25 works, and it gives you 5. So you always write the perfect square in front. 125 divided by 25 left me with 5. And then this one stays the same. Now I just write it all out. The square root of 25 is 5. I can't take the square root of that. And square root of negative 1 becomes I. The correct order is 5I radical 5. You just learned how to simplify radicals and what an imaginary number is. Have fun practicing.